Hello everyone, my name is Arsh. I'm at the chill guy on Slack. I work as a software engineer at Philos. And today I'm here to talk to you about how to build an FWS dApp, what are the main hook points and tools that you have available, and also point you to where you can go for help. And hopefully it will be worth your time. So let's dig in. On Friday, I showed a demo app called Hot Vault, which was an end-to-end FWS dApp for a drag and drop pay-as-you-go Google Drive with on-chain stablecoin payments. So let's work. A picture is worth 1,000 words. So let's walk through an architecture diagram of how that service was built and how you could build something similar or vastly different. So can you guys see an architecture diagram on my, okay, awesome.
Yes.
Yeah. Okay, great. So let's get started with this. You're a dApp developer, or even you're a smart contract builder. What is the flow going to look like for you with the contracts and tooling that we have available for you today in FWS? You have an end user that goes to the dApp UI. You have a dApp backend. This is something that you would have to build depending on what dApp you're trying to build. We have something called PDP tool, and the slides have linked to all these tools. PDP tool is a client to allow your backend to store and retrieve data on a Filecoin SP that provides hot storage backed by PDP proofs. Okay, so it's written in Golang. It has a very easy to use interface. It allows you to upload files, retrieve files, create proof sets. Proof set is like a container of storage in PDP. Think of it as like a container that you can get on Google Drive or like an S3 bucket. It allows you to create proof set. It allows you to add files to an existing proof set. It allows you to download files that you are proving in a proof set. So it is the client software that you would use. It has a nice CLI interface. You would use it in your backend to talk to a Filecoin SP that provides hot storage backed by PDP. Then the Filecoin SP, you need to find an implementation like Curio, and a Filecoin SP implementation like Curio already integrates with the PDP verifier contract. And the PDP verifier contract is already live in mainnet. My friend Zen is going to talk about it in detail in the next talk and how you can program it. PDP verifier contract is already live on mainnet. A Filecoin SP implementation like Curio already has integration with the PDP verifier contract. So if you're talking to a Curio storage provider using PDP tool, you can get your data onboarded and proven to the PDP verifier contract right away. And once you do that, the SP has to prove the data that you're storing every 24 hours. You can even change this duration, and Zen will go into detail about it. But what I want you to take away is that the PDP verifier contract is highly programmable. Now, the main thing that you would have to build is a for PDP, for example, we plan to ship more FWS services in the future. But today, for the sake of this talk, let's talk about PDP because it's already on mainnet. It's working well. We've tested it. We've shipped it. So if you're building an FWS dApp on the PDP service, what you would have to build is a PDP service contract or an SLA contract. This SLA contract basically sets the terms of your dApp for your users. For example, in the app that I built, that we built, and that we showed on Friday, Hot Vault, the PDP service contract basically enforces that the SP has to prove the data that you're storing every 24 hours. If they don't do so, then they don't get paid for the epochs that they don't prove. And so the PDP service contract or the SLA contract basically hooks on to the PDP verifier contract. When you create a proof set, you specify the address of the service contract that you want the PDP verifier to use for a given proof set. And then for all actions that you take with the PDP verifier contract, that the SP takes with the PDP verifier contract, such as adding data, removing data, proving data, etc., the PDP verifier calls into the service contract slash SLA contract that you hooked on for your DApp. So you receive callbacks for each and every action that the PDP verifier takes. And if your contract reverts for a given callback, the entire transaction reverts. So you need to make sure this implementation is rock solid. But you can set the terms of your DApp here. The SLA contract, we can also call it an arbiter contract because this also hooks on to the payments contract. I will talk about the payments contract in detail in a minute, but this is one more piece of software that we've shipped for builders today. It's a very well designed payments hub for the entire FWS marketplace that provides point-to-point payments between a client and a service provider with lockup and arbitration. Any FWS service, such as your PDP service contract, can use the payments contract to facilitate payments in any ERC20 token. USDFC, for example, retrieval, for example, any token of your choosing. You can even deploy your own if you need one for your DApp. It can facilitate payment in any ERC20 token between the client and the service provider. The client could be the end user of your DApp if they want to have a wallet and manage their own keys and funds. Or the client could be you, where you abstract out the details of using Web3 or using crypto from your end users, manage all this complexity for them, and you could be the client for a deal on the payments contract. And you could pay the service provider on chain through the payments contract. So that depends on the business model and the UX that you want to give to your clients. Both flows are supported. The payments contract doesn't have opinions on who gets to be a client slash payer and who gets to be a provider slash payee for any transaction or deal. So what I'm saying is this service contract that you build can also be, or probably will also mostly be, the arbiter on a payments rail. I'll go talk about what rail is in a minute. Think of it as a lightweight payment channel to enable point-to-point payments for a specific deal as defined by your DApp between the client and the SP. So the payments contract, the client locks funds in the payments contract. The nice thing is, because this payments contract is like a one-stop shop payments hub for all FWS services and the entire FWS marketplace, the client, either you or your user, can lock funds into this payments contract, can deposit funds into this payments contract once and then disappear. And as long as they have enough funds in the payments contract, multiple services, multiple dApps, multiple service providers can use those funds to pay for their services without you having to do much on-chain interactions. The payments contract provides this nice UX to clients of deposit money once and then use it for as many services and deals and service providers as they want. We aim for it to be like the Stripe. I don't know if it's a perfect analogy, but yeah, we aim for it to be the Stripe of FWS. So the clients deposit funds once here. They lock up funds to guarantee payment for a certain number of pre-agreed fixed epochs. It could be 1 month worth of epochs or 6 month worth of epochs. They lock these funds up to guarantee service providers that they will get paid for a pre-agreed number of epochs no matter what happens. However, these funds can only be claimed by the service provider if the SLA contract says yes. This means, for example, in the context of PDP, this means that only if the proofs are submitted by a Filecoin storage provider on time and after the PDP verifier notifies this SLA contract that the proofs have indeed been submitted correctly, when the service provider tries to withdraw funds from the payments contract for the epochs that they have already submitted proofs for, the payments contract will consult your SLA contract slash arbiter contract to determine how many funds actually should be transferred from the client's locked balance to the service provider. So this is highly programmable. It's programmable both on the PDP side, where you can hook into every action that the PDP verifier takes based on SP inputs, and it's programmable on the payment side, where you can control how much funds and for how much duration of services are funds actually transferred from the client to the service provider based on this pre-agreed SLA slash arbitration being met. And I'll link you to some concrete examples of how to build a contract like this in a minute. My main aim over here is to convey to you that both the FWS service, such as PDP, and the payments contract are highly programmable and are pluggable slash modular. In payments contract, you can plug in how this arbitration happens, which determines how much service providers actually get paid. Now, for something like PDP, you already have cryptographic proofs, which makes building the arbitration contract slightly easier because you can verify proofs and then have a policy of how much service providers actually get paid based on whether those proofs are correct or not. But hey, you could even build an arbitration slash SLA. We need to fix a naming here. Sorry. So let's just call it the SLA contract right now. You could even build an SLA contract for the payments contract that uses DAO voting. A DAO, members of a DAO could vote on whether a certain payment should happen or not based on pre-agreed terms. You can even build an SLA contract that takes a data feed from oracles, and now you can have real world data flowing and feeding in to your payments decision between clients and SPs. So you can be as creative as you want with the SLA contract. And the payments contract will consult it before settling any funds between the client and the SP. The payments contract also has a notion of a broker fee or a commission or an operator fee. These are multiple terms for the same thing, which is basically that when the service contract creates a payment channel between a lightweight payment channel, which we call a rail, when it creates a rail between a client and a service provider, it can configure a pre-agreed upon broker commission, which will get paid out to the service contract. So you, as a builder of a service contract, this is how you would make money, is by getting a percentage of all funds that are settled between the clients and the service providers for deals and rails that are created by your service contract. So the payments contract, and this can be zero as well. It depends on what your business model is, but the payments contract supports this commission slash broker fee. It supports building out a custom arbitration. The PDP verifier contract allows you to plug in your own listener slash SLA contract. So this is the contract. It could be multiple contracts. It could be one contract that is both acting as the listener to the PDP verifier and acting as an arbiter to the payments contract, or it could be two different contracts. But this is what you would have to build. I'll point you to an example of a contract we built out for the Hot Vault drag and drop file storage app. But this is what you would focus on building out. The PDP verifier, the payments contract have already been built out for you. The PDP tool has already been built out for you. They have been battle tested now. Payments contract still needs to go through an audit, and we'll keep you, please follow the Phil FWS channel, and we'll keep you posted on the audit status. The Curio implementation already supports the PDP protocol. So that's already been built out for you. You would have to focus on building out the arbitration and SLA contract. You would have to focus on building out, of course, your DApp UI, your DApp backend, and figuring out your business model. Do your clients log in with their wallet? Do you handle the complexity for them? How much commission do you charge in your service contract for your business? And things like that. You would figure out your pricing, and hey, the pricing terms of how much the client needs to pay for each epoch in a rolling payment system like the payments contract implements. So you figure out the payment terms, you figure out the slashing policy, you figure out the arbitration policy, and encode all of that into your SLA contract. So you'll have to figure all that out based on, your dapp's business model and your dapp, what UX you are looking for in your dapp. And we've already built and deployed a PDP subgraph for the PDP verifier contract on Gold Sky. We are currently beta testing it. We're also going to build a subgraph for the payments contract. We're going to build a DApp widget for the payments contract, which you can integrate in your DApp. And that makes it easy for the clients and service providers of your DApp to interact with the payments contract. Like imagine integrating this widget into your DApp, and now users can use it to withdraw funds, deposit funds, lock up funds, settle payments that they are owed, etc. So we're also going to ship that for you. So not just the contracts, not just the PDP tool, not just the SP support for these contracts, we're also shipping subgraphs. We're also shipping a DApp for payments that you can integrate in your DApp widget that you can integrate in your DApp. We've already built an explorer for PDP, for the PDP service that you can like go to today for both Calibnet and Mainnet and see all the action that is happening, and you can point the users of your app to that explorer if you want to, or build your own explorer using the subgraphs that we're going to ship. Depends on what you're looking for. We're also going to build an explorer. So the explorer for PDP is already built. Now we're going to build an explorer for the payments contract as well. The work on it is already started. So yeah, it's a whole host of tools and programmable smart contracts and SP integration for those smart contracts and explorers and subgraphs and so on, to make it as easy as possible for you to deploy your app. Figure out your business model, figuring out your price, figure out your arbitration and SLA and pricing and slashing policy, build out the SLA contract, integrate the PDP tool in your backend, and you can get going as fast as you wanna. So let me just quickly walk you through the payments contract. Yeah. So the reason I want to talk about the payments contract is understanding how it works will give you a good idea of how to build your SLA and arbitration contracts, and will give you an appreciation of how programmable it is, and it is generic and reusable enough to support a whole variety of use cases. So yeah, this is the payments contract. Can you guys see my slide now? Okay, awesome. So this is the payments contract. Like I said, it supports point-to-point payments with lockup between a client and a service provider in any ERC20 token. You can do fixed one-time payments with it, where I can just send you one USDFC and we are done. Or you can do rolling payments with like rate-based rolling payments per epoch, where we can say every epoch I'm gonna pay you one USDFC, and the client has to lock up funds based on pre-agreed duration with the SP. It could be 0 epochs, it could be 1 month, 3 months, 6 months, depends on the terms that you want for your app, and the client has to lock up those funds, and the SP can settle those funds and receive them for the epochs that it has already provided services for, as long as the arbitration contract agrees with that settlement, which is the arbitration contract is what you would build. So this is a summary of the payments contract, and it supports a whole variety of use cases. We already integrated it with the PDP. We built our own SLA and arbitrator contract for the Hot Vault demo app, and it was a breeze to integrate it with PDP, which is what makes me confident that it's probably a good fit for your app as well, and you don't need to rebuild your payments layer from scratch, because not only is it hard to get right, but auditing is expensive, and any bug in there can be really expensive. So before you choose to build out your own payments layer, do talk to us, and we can definitely help you integrate this payments contract into your service and app. And we are highly confident you'll probably find it to be a good fit. So there's an account, a client has an account, a service provider has an account with balance and lockup and more information. A rail is like a lightweight payment channel between a client and a service provider, both of whom are accounts in the payments contract. The client can be you, it can be your DApp, it can be your end user. The service provider can be the service contract itself. So the service contract itself, the SLA contract that I'm talking about, can be the end, receiver of the payment channel, or it can be the service provider of the deep in service who's actually providing the resources. All of this is programmable. You decide what business model and flows you want. Okay. There is the operator contract. Operator is basically the same as the PDP service slash SLA contract that I was talking about. It is the operator contract that creates these Rails, sets the payment terms on how much lockup is needed and how many epochs the lockup is going to be for and how much fixed payments are going to happen. What is the per epoch rate of this payment channel slash rail. I'm now gonna, from now on, I'll refer it to as a rail. So operator contract is what you are gonna build out for your DApp. And again, we're gonna go back and fix all the terminology to make it extremely homogeneous, FWS wide. But operator contract is the SLA contract or the arbiter contract that I just talked about. Then there is an arbiter contract. Like I said, it can either be the same as the operator contract or it can be some other contract that you get to decide. But basically, when an operator contract creates this rail, it sets the address for the arbiter contract. The arbiter contract has to satisfy a certain interface that the payment contract expects. But then every time before settling a rail and before a service provider can receive the funds they are owed from the client lockup, the payments contract will consult the arbiter contract on how much funds should actually be transferred or slashed and how much funds should be returned to the client. So these are the contracts that you would implement. And like I said, go creative. This contract can consult an oracle. This contract can be based on DAO voting, all highly programmable. You decide what's needed for your DApp and service. Yeah, so the client deposits funds into the payment contract, any ERC20 token, including USDFC, which is a Filecoin backed stablecoin. If you need the stability of a stablecoin for your DApp to make it easy for clients and service providers to transact with relatively less volatility. So deposit any ERC20 token, lock them up. The operator creates a rail which between a client and a service provider. The client locks up funds in that rail based on pre-agreed terms of lockup. And then every time the SP wants to get payments for services they have already rendered, they ask the payment contract to do a settlement. And before doing the settlement and transferring the funds to the SP's account within the contract itself, it consults the arbiter contract that I've described here. You get to decide what the arbitration contract does, and the arbitration, based on the decision of the arbitration contract, funds are transferred from the client's lockup to the service provider. And the nice thing here is, like I said, because of lockup, the service provider is always guaranteed payments for a certain number of epochs. And after those many epochs, if the client doesn't have enough funds to pay for the next lockup period, the SP can either ask the client to deposit more funds or terminate and exit a rail. So as an SP, as long as you keep settling every lockup epochs, you are guaranteed you will never not be paid for any service you have already given. And the payment contract comes with that guarantee. And the client can also set an allowance on how much funds an operator is allowed to lock up in a rail, how much maximum payment can be done every epoch. Think of it as like the ERC20 allowance pattern. Think of it as something similar, but it basically limits the maximum risk that a client is exposed to by transacting with a certain operator contract. So all these bells and whistles and safeguards are already in there for both the client and the SP in the contract. Yeah, I don't want to go into too much detail. The payments contract already has good docs. If you go to the README, here, this is where you'll find the payments contract. This is where you find the hot world demo, which has the client and the server code for the DApp, the drag and drop file storage DApp with stablecoin payments using the payments contract. And we have a PR about to be merged. And this PR implements the SLA contract and the arbiter contract for Hot Vault, which will show you how to hook into the PDP verifier contract and the payments contract to build out the terms needed for your DApp. So do go through these resources. We are in the process of putting them in really good docs, so you don't have to go looking at pull requests. Should be done soon. Uh, yeah. So
Thank
yeah,
you.
yeah. I'll just wrap up here. Is Yeah, subgraphs. We're building subgraphs. We're building explorers. We're building dApp widgets. More FWS services are coming soon. Like I said, docs and cookbooks for payments, PDP, and FWS services are coming soon. The Explorer for PDP is already live. The subgraph for PDP is already live. We're gonna be partnering with amazing like Philby team and Sarah and Longfei and others to build out the DX here. And please follow the Phil FWS channel for updates. Ask any questions whatsoever. We are here to help you build out your service and app. And this is me on Slack, DMs, and yeah, always welcome. And any help you need, I'm there to give you. Thanks a lot.